That's it. I can see it. I've made it. I'm there. God, how red it is. It has fascinated men since they first gazed at the stars. Yes, I've made it. In a minute, I will tread the soil of the planet Mars.
Plan is nominal.
Just a few more meters, and it will tell me its secrets. About water, about life, and perhaps above all, about the origins of mankind. It's a dream, of course. It's my dream. But it will become reality. One day, astronauts will go to Mars. My name's Thomas Pesquet. I'm an astronaut. I'm in training for a mission, 6 months in the International Space Station. I think future space conquest is very important for everyone. The further we look into space and the more we look at our past, it's clear that a planet like Mars is where our future lies. We're advancing in an environment which is difficult, but we're advancing quickly. It's an incredible journey. Let's pursue this adventure together. You won't be disappointed. When you're an astronaut, Mars is the Grail. Mars is a dream for me and for my colleagues too. When we replied to the job offer for choosing astronauts, it was already mentioned in 2009 that one of the destinations would be Mars. So we all applied for that. We all have the explorer in us. I can see it in myself and in my colleagues. They've worked in the Antarctic, on volcanoes. We all have the travelling and exploring instinct in us. Before it fascinated space explorers, that ruby-like glow in the night intrigued the first astronomers, Greek, then Roman. In its red colour they saw the mark of blood, and since blood means war, they related it to the god of battle, Mars. Then very quickly, the planet where blood and death flowed began to be seen as the planet where water and life flowed. Mars is the twin sister of Earth, a parallel which appeals to me. The blue planet, the red planet.
Some say that Mars is the twin sister of Earth, some say it's Venus. It all depends on which criteria you use. From a size point of view, it's Venus. Historically speaking, Mars, particularly 4 billion years ago, quite probably bore an astonishing resemblance to Earth. Life appeared on Earth. Life appeared on Mars. At least, you might think so.
Personally, I believe in life on Mars, and it's always a fascinating debate, because people like to believe in life elsewhere. It's one of those big questions which is clearly important for everyone.
You have to appreciate that Mars is the object in the universe the most mechanically accessible by our probes, where the question of other life forms exists. That's where the answer will be easiest to find, if we find it.
So to find out if our twin sister could have harboured life, let's go through the looking glass. Baikonur Cosmodrome in Kazakhstan. It's arrived at last. It's a probe called ExoMars. Conceived by the European Space Agency, it is assembled today in the rocket which will propel it towards the Red Planet. It has a capital mission: to study the composition of the Martian atmosphere and detect the traces of any gases.
All that will provide us with information on the history of the Martian atmosphere, which relates directly to the history of Martian water, which itself relates directly to the eventual history of Martian life.
For the moment, the probe still has to get to the Red Planet, and for that, the rocket Proton is going to provide a serious helping hand. A successful launch. But for the engineers at the European Space Agency, it's just the beginning. Based near to Frankfurt, they remain mobilized. "10 hours after the launch of the probe, for them everything starts. Because for the moment, ExoMars is still dependent upon the rocket. It's a fragile toy which needs to gain autonomy and follow the correct trajectory. But will it be able to? The last stage of the rocket detaches. ExoMars is on its own. The engineers await a sign of life.
We are just waiting for the first telemetry to come in. As soon as the decoding, the signal is better. Yes, yes, yes. The spacecraft is still in SAM, yeah?
That's correct.
Still, and then the spin is stable.
That's correct.
The probe is ready for the chase. A chase through space during which it will have to catch up with Mars, which, like itself, is turning around the Sun.
The transfer takes 7, 8, 9 months from Earth to Mars, between the two orbits, and the distance which ExoMars will travel in relation to the Sun is in the region of 500 million kilometers.
The beginning of a very long odyssey. We'll follow it together, and at each hurdle, I will tell you if man, like ExoMars, can jump it. And the first question, why is a robot leaving today for the Red Planet, and not a man?
For the moment, we send robots because we don't have to bring them back. That's the first point. For the robot, it's a one-way trip. The second thing is that we don't have the know-how.
It takes a lot of energy to propel a vessel into space. And as load increases, so does the energy needed, and thus the size of the rocket. And man is very heavy. For him, the rocket needs to carry fuel, water, apparatus, oxygen, food.
The problem with a manned mission as opposed to a robotic mission is the mass you need to send. The fact is, you need to send a mass of around 30 to 40 tons to Mars, whereas today we send more like 2 tons. A manned mission would require a very large rocket, what we call a heavy lift launcher. That's what the Americans are developing with their SLS launcher, which should be flying in a few years.
One of the motors for the future SLS has just been ground tested by NASA. The 2-minute firing up burnt 630 tons of fuel. The test was conclusive. In a couple of years, this giant rocket should be able to take off into space for an initial test flight. But despite its power, and before even dreaming of a manned mission to Mars, solutions need to be found for reducing the payload to be sent towards the red planet.
In terms of weight of materials, we may opt for inflatable living quarters, for example. This year, an inflatable module will join the orbiting International Station.
We checked all 4 systems, and there you go on modulation, all 4.
The module is inflatable and therefore light.
It has no power inside, no lighting, so anytime the astronauts will be going in, again, 3 to 4 times a year for several hours to collect various sensors that are taking temperature data, radiation data.
Radiation. Yes, in this inflatable module, levels of radiation present in space will be measured. Vital information. Because when man has worked out how to travel light, thanks to things like these modules, he will need to board a vessel like this one, being developed by NASA. A vessel which I would love to pilot one day, and which, in the same way as a boat must battle against tempests, will need to tackle radiation. Radiation which is as harmful for us astronauts as it is for robots, even though for them it's not a question of life or death. So what is this radiation, and what protection is there? For the moment, it is ExoMars which is battling it.
As soon as a spacecraft leaves the Earth's proximity, it enters free space and no longer profits from the Earth's magnetic field for protection against certain radiation.
And this free space is a field of stars which are sublime when viewed from Earth, but from up there they can sometimes be fearful when they explode. These are supernovas. They give out a phenomenal amount of very aggressive energy, which spreads out across the universe. This is one explanation of the origin of cosmic radiation. The technological armory of ExoMars could suffer from this during its journey.
That's why it has thermic protection around it and protection around the engines. But there could still be a wearing effect on the electronics, which could cause dysfunction in a certain number of elements.
In this respect, we astronauts would of course be even more fragile than robots.
The principal problem with these high-energy particles is that they provoke recombinant DNA. That is to say, they produce genetic accidents which can result in aberrations, in illnesses. Either, in the best of cases, the cell with aberrations dies on its own, which is apoptosis, or it doesn't die and starts causing all sorts of trouble. And that's what can eventually lead to cancer or other cellular problems.
The International Space Station, the ISS, is close to Earth. So we are less subjected to radiation than in deep space. But the day we travel towards Mars, we will receive 300 times more than on Earth. What will the consequences be? Scott Kelly will provide an answer to this question. He's never been into deep space, but he's just returned from his latest mission aboard the ISS, meaning he has spent a record-breaking 520 cumulative days up there. This year-long mission was designed to evaluate the physical effects of a long voyage, such as that which would take us to Mars.
Scott Kelly returned after 340 days in space. NASA's one-year crew member conducted a lot of very important research back down on Mother Earth.
Over several years, his health will be scrutinized by doctors and compared to that of his twin brother. The impact of radiation will be evaluated. When we leave for Mars, the journey will last at least 6 months, and the same for the return, with more than a year and a half on the ground of the red planet. That makes nearly 3 years in space. The radiation received could reach the acceptable limit for a human being. Another danger has the same devastating effects on man's cells. Solar flares. They can sometimes last for several hours. They release an enormous quantity of high-energy particles which flood space. During its journey to Mars, a crew could be killed in the space of a few minutes. But in this case, there is a means of protection.
Concerning the sun's rays, when there's a flare, it will be necessary to take cover inside a sort of armored zone surrounded by water. 15 to 20 centimeters of water is sufficient for a solar flare to be rendered acceptable.
In the same way that robots and men suffer from the sun, so do planets. That's what's dramatic in the case of Mars. And this needs to be understood to appreciate why the planet of my dreams is such a hostile world. A world which will not be easy to conquer. Because the sun generates solar wind, a breeze which aggresses everything in its path. One planet is protected from it, Earth.
Earth has a protective shield. This shield is its magnetic field, which protects it from solar wind. The sun blows a wind of particles, protons, hydrogen, helium, which eventually tear away a planet's atmosphere. But we're behind our magnetic shield.
The aurora borealis, which can be seen from the ISS, is a result of this phenomenon. The magnetic shield deflects the solar wind towards the poles, where it meets the atmosphere and produces this light show. The atmosphere is this thin golden film which is also protected by the magnetic field. A magnetic field resulting from the movements at the heart of the Earth's nucleus. Half the size of the Earth, Mars, after being formed more than 4 billion years ago, was protected from solar wind in a similar way.
A phenomenon then came about due to the fact that Mars is small. The internal source ran out, causing everything to seize up inside, and its magnetic field was broken.
This breakdown had grave consequences for the atmosphere of the little red planet.
Mars no longer has a magnetic field to protect its atmosphere in the way that the Earth is protected today. When this protection stopped, its atmosphere came into direct contact with the ions from the solar wind, which bombarded it, causing its atmosphere to escape.
No more atmosphere, and therefore no more greenhouse effect to retain warmth, and therefore no more liquid water. Mars became a completely naked planet faced with the aggression of space. A planet both naked and hostile.
It's much further from the sun than the Earth is, meaning that today it is a frozen desert. It's 0 degrees at midday in summer. It's about minus 100 degrees at night. That's Mars today.
The point of sending robots is to better understand the past of the red planet. How I would like to be in ExoMars' place, when after a 7-month journey the probe at last begins to orbit Mars. It will fly over the immense canyons, gigantic volcanoes, with sand everywhere. I'd go anywhere they asked me to go. I love the mountains and the absolutely magnificent volcanoes on Mars. Olympus Mons, for example, Elysium Mons, they interest me because I love mountains on Earth. But they're not really favourite landing sites for a space mission. So I'll go where I'm told to and look at the mountains in the distance and take photos. In the meantime, it's probes which take the pictures. The colours sometimes being treated to bring out different elements of Martian geology. There's the polar ice cap. I particularly like it. Its ice has inflamed many an imagination, and that helped feed the desire to conquer Mars.
Touchdown in just over 1 minute.
Yes, our imaginations turned Mars into much more than a planet. A myth. A myth which was born in the 17th century when the first telescopes turned towards the red planet. And what did the astronomers discover there?
The first thing you see with the spyglass is a little white mark, which is the southern polar ice cap. And if there's an ice cap, that means water. And if there's water, then there's probably life. The myth stems from this little observation.
So, by linking the ice caps on Mars to life, the imagination of the time invented Martians. More precise observations were to follow, including those of the eminent astronomer Schiaparelli, which greatly reinforced the myth.
Schiaparelli, by some unknown miracle, detected canals during his visual observation by telescope of Mars. He drew a plan of these Martian canals and explained that they were made to bring water from the poles towards the equator. And to his way of thinking, along with many other people, Mars was inhabited by Martians who built these canals.
The most famous astronomers of the time, including Camille Flammarion, added their weight to this theory, and very little doubt was cast on it.
Photos didn't exist. You made visual observations, which you then drew. You observed, you drew. You observed, you drew. The problem is that you have atmospheric turbulence. Meaning that extremely precise observation can take place for just a few seconds. So within the same team, in the same observatory, the same room, some were convinced that they'd seen canals, while others said, I didn't see any. That all went on for about 50 years.
Scientific progress swept aside the idea of canals, but the myth remained entrenched in people's imagination.
The moon is too close. I'd rather go to Mars if possible.
But Mars is a bit far.
I hope there are human beings living in these places who are much more intelligent than on planet Earth.
Proof was needed. Launched in 1964, Mariner was the first American probe sent to Mars. Nobody yet knew what the red planet really looked like.
There she goes. That's data.
Over the course of 2 days, it performed a flypast of Mars and sent back the first images. But this incredible success was more or less overshadowed by the immense disappointment which went with it.
The first images were black and white and of low quality, and people said, it's not interesting, it looks like the moon.
But the myth continued. The American Viking mission was launched to look for traces of Martian life. And in the harvest of photos of the red planet which the probe sent back, the myth once again managed to slip in.
There is one quite astonishing image.
It's true that in the collection of images, there is one particular one known as the face on Mars.
You can see a sort of face with 2 eyes, a nose, a mouth, and an outline.
And a lot of people started to fantasize about it, saying, it must have been built. It's a sign.
It was extremely intriguing, and right up until the 90s, NASA came under a lot of pressure from people telling them to take more photos of this same face to confirm that that's what it was.
A probe once again found the site of the face, but the shadow and light play that day were not the same.
And this time you see it's a banal 1.2 kilometer long hillside.
It's quite clearly a mountain and doesn't look at all like a face. I suppose it's like on Earth when you look at clouds and invent your own story. People had read the story of man into this face.
From a simple ice cap, man conjured up on Mars the idea of another self.
So there's a real myth, a myth which carried us along and became a scientific adventure. And the more we pursue this adventure, the more we find ourselves saying, Martians, why not?
And there lies the moral of the story. Why not? Because, look, as you arrive over Mars, you can easily distinguish a sign engraved into its crust, a sign linked with life. That of water.
There are traces of a flow. And a flow suggests a stream. And if a stream is very long, it becomes a river.
A dried-up river. That means water has flowed and dug a canal. A torrent erodes the ground, and what's more, we see water-shaped forms going round the craters.
And when you look at a morphological formation, you say to yourself, ah, it flowed, and then it turned. There's a meander. And then there's a delta. In fact, yes, water has flowed.
It's as plain as the nose on your face that water did that.
That means that we're right to want to go there because water is obviously an essential constituent of life. It also means that it may still be there in the form of bacteria and things like that. So going to Mars is something we focus upon in space exploration because it's going to answer some important questions. There has been water on Mars because there was an atmosphere at the time when it had a magnetic shield to protect it. An atmosphere which allowed this water to neither freeze nor evaporate. So Mars really was the twin sister of Earth. To find out more, ExoMars is going to scrutinize this Martian atmosphere from right up close. But the European probe has a second mission, a mission which concerns me personally. Thanks to this probe, I could perhaps one day land on Mars.
Europe wanted to acquire the techniques and understanding necessary for landing a sizable mass on the surface of Mars.
So the probe has taken a guest with it. This is Schiaparelli, which will become autonomous 3 days before going into orbit around Mars.
Schiaparelli, which takes its name from the Italian astronomer who came up with the idea of Martian canals, is solely there to demonstrate a landing.
It will try out European know-how about landings while the other part of the probe is analyzing the atmosphere. Schiaparelli faces a sizable challenge because an object trying to land on Mars arrives at a staggering velocity, 6 kilometers per second, since the planet has virtually no atmosphere to act as a brake. Another European probe, Beagle 2, knows something about it. It arrived on Mars, yes, here precisely, but...
Unfortunately, we know this now because we found it, it didn't completely open up. So it landed, but we don't know how or at what speed.
Its wreckage illustrates the fact that, for the moment, no one particularly wants to take the risk of trying to land men on the Red Planet. Will Schiaparelli come to the same end? I can't tell you, because it hasn't arrived yet.
We're standing by for guided start and start of guided entry.
But here is another of its predecessors, American this time. It's called Curiosity. For this mission, NASA came up with a totally innovative technique for landing the probe, never before seen or tested.
We're at 15 kilometers altitude.
The device to be landed weighed a ton. Never had anyone placed something so heavy on Mars.
The landing was a nightmare because I don't think anything so complicated had ever been done. They called it the 7 minutes of terror.
We've lost towing from Earth at this time. This is expected. We're continuing on out of the run. Parachute deploy. Parachute. We are decelerating.
You open a parachute, but because of the low density, you still descend at 200 or 300 kilometers per hour. You can't land by parachute on Mars. You need to brake using rocket motors just at the end.
We are in powered flight. At an altitude of 6.5 kilometers and descending.
The vehicle itself weighed a ton, and they wanted to be sure that it was correctly deployed. And for that, they had to be able to direct the landing.
500 meters in altitude.
The easiest is to place yourself overhead.
Standing by for sky crane.
Choose where you want to put it and place it. And that's how they came to invent sky crane, which is a powered crane with a wire which descends and places the object where you want it to go.
Sky crane is started. 40 meters altitude.
Stable.
Touchdown confirmed. We're safe on Mars.
Other devices had already landed on Mars, but never this heavy. The way had just been majestically opened for the men who will one day tread the soil of the red planet. It's a vehicle, a rover named Curiosity because, by means of its search head, it attempts to understand if Mars could at some time have been capable of supporting life. It was already at work.
Got thumbnails. It's the wheel! It's the wheel!
The first photo had already been sent. Curiosity is a dream which became a reality. A dream which cost $2.5 billion all the same. Covered with a dozen or so instruments, a weather recorder, a camera, a spectrometer and a laser, amounting to 80 kilograms of scientific material, today the little rover has a whole planet to explore. But is there anything to be found in the midst of this rust-coloured landscape, on this soil red from having been oxidized, altered by cosmic and solar rays?
These rays have finely chopped, as you might say, all the eventual prebiotic molecules which might have existed in the soil. When I say finely chopped, I mean that these molecules have been destroyed and have oxidized, producing CO2, which then escapes.
Prebiotic molecules are the first bricks necessary for the emergence of life. Curiosity will try to find them, be it only a trace, and to do that, it will shoot.
There's a marksman in all of us. As soon as we see a stone, we like to shoot at it because we'd like to know what it's made of. This one has so much magnesium or calcium or iron, so we're going to start shooting.
At a distance of up to 7 meters, Curiosity's laser is capable of instantly analyzing soil and rock composition. This laser is called ChemCam. It's a Franco-American tool. Its replica is in Toulouse. It was conceived by researchers at the CNRS and several French universities.
Tout marche bien?
Tout marche bien là, ouais.
On fait une dernière série, peut-être?
Today, ChemCam is going to analyse one of the elements which makes up prebiotic molecules and that we'd like to find a lot of on Mars, carbon. And it's going to practice on samples of carbon from Earth.
I'm putting the Mars atmosphere.
This atmosphere is reproduced so that ChemCam has all the chemical ingredients of the Martian environment, so that its analyses are as faithful as possible. Then it will start shooting at the different samples.
Look, you can see it. It's in the process of firing. We're going on to Mars.
The heat of the laser on the samples transforms microscopic particles which will then be analysed.
Here you have the whole spectrum. You can see a carbon ray right here. If we see carbonates one day, we'll be more or less the first to see them because this remote control exploration allows us to slightly guide the rover in its more precise analyses.
ChemCam has all the necessary data for the rover to one day be able to recognise on Mars these carbonates in possible correlation with life. But will it find any? That's the hope of the laser's developers in Toulouse at the CNES, who work every evening in American time directly with NASA. Here, night after night, along with the Americans, Curiosity's movements are programmed in relation to which rocks they would like it to analyze.
But if you look at the Big Sky TRT, it's quite similar to COMAS, except there's...
Maximum concentration is necessary because the slightest error could perturb the rover's functioning.
Big Sky, so it's going to go down a bit, and it's not deviation.
We've just finished a study of the dunes on Mars, which was a great achievement, and we've just gone up onto a plateau, which is quite astonishing in terms of the diversity that we see there. We really have the impression that a complex history is unfolding before our eyes, which we haven't yet understood, with different stages, almost different stories.
Stories which sometimes have misleading appearances. That's what Curiosity's drill would demonstrate, perched on the end of its robotic arm. It was making holes in soil which had been oxidized by rays and in principle was therefore incapable of preserving life. Through drilling, Curiosity brought to light a new perspective.
When it started drilling, it demonstrated that underneath, you no longer had that rust color.
Curiosity drilled a small hole, and when the powder came out in the command room, we were astonished to see that it was completely gray.
This grey powder, collected a few centimetres under the surface, was analysed in the rover's internal laboratory. The researchers noted that, contrary to the soil on the surface, it hadn't been oxidised. Curiosity had thereby shown that it could potentially sustain life.
NASA demonstrated that this environment was habitable. So, what does that mean? It means if we go back 4 billion years, when the temperature was a bit higher and there was liquid water, that this rock could have small bacteria living in it.
To be able to demonstrate that 3 billion years ago, Mars was a habitable planet. That's extraordinary. In the solar system, there are 8 planets. Up until 2 years ago, I only had one which was habitable. And that was Earth. Now I have 2.
A habitable planet doesn't necessarily mean an inhabited planet. But the discovery was crucial. To this day, Curiosity has made 350,000 laser shots. In 4 years, it has covered 14 kilometers. As though looking for a needle in a haystack, it continues to hunt for molecules necessary for the appearance of life. Curiosity is a formidable achievement, and I take my hat off to all those who've worked on this project. But scientists are a bit frustrated because they send a command, and then up there you have to wait to be in communication with the robot, that it integrates the order, tries to carry it out, there's a little problem. Basically, in 24 hours, you've covered 2 centimeters. The astronauts on the moon covered 200 kilometers in their little moon buggy, so scientists say they can't wait to send people to Mars because the scientific return will be so much greater. But when will space agencies finally send astronauts to Mars? In the meantime, an association has grabbed the initiative and started testing Martian exploration conditions on Earth. Any traces of past life on Mars will certainly be found deep down, perhaps in collapsed craters.
Lucy, can you come down?
Okay.
One of the activities of the International Association Mars Society is to test clothing and spacesuits. Today in a cave in Normandy which resembles the collapsed craters on Mars. Alain is an engineer on the Ariane 5 rocket. Lucy is a student in space botany.
You'll have to get lower.
Okay.
Yes, good.
You can see how difficult it might be to move forwards in somewhat tight corridors while wearing a bulky spacesuit. You can also see that a lot more effort is needed.
The principal question is how to optimize all that. Spacesuits adapted to Martian exploration, particularly lava tunnels, caves.
Detailed reports are then made of these simulations, which are transmitted to space agencies to further their studies and reflections. But this sort of association has another objective: to keep the dream alive, that of man's first steps on Mars. The association even has a Martian habitat, set up somewhere in the Utah desert in the United States. But even when you're passionate about Mars, you have to one day come back down to Earth. They carried out this experiment together in the Utah desert. Alain and Olivier and Pierre, 2 architects specializing in space, collected ideas for a Martian base, the model of which is presented whenever a scientific conference evokes the conquest of the Red Planet.
We've used powdered brick or roof tiles to represent Martian dust. Here we had something very important, which is one of your ideas that was tried out in Utah. It's a balloon.
A balloon carrying a camera to follow the movements of the astronauts. As for success that day,
it didn't work very well when we tried it in Utah.
Yes, it did. Eventually, yes.
I think we have all the figurines. We've built all the living quarters in a valley for 2 main reasons. Firstly, as protection from the sun's rays, and then it's useful for the orientation of the solar panels
towards the sun.
Here you have the energy module, which centralizes and capitalizes all the energy produced by the solar panels.
If we use solar, that is.
If we use solar. If it's a nuclear reactor, in any case, it will be a kilometer away and partially buried.
All that will need to be considered once on Mars. The problem of energy and the lightness of materials.
The great advantage with this concept is that the inflatable part can be placed either high up or on the banks for the greenhouses, for example.
The eggs on the side are inflatable. These are the greenhouses.
The greenhouses, yes.
These associations are actively committed to reflecting on the conquest of Mars because, to their taste, it's too slow coming. I believe engineers need to be given time. But it's true that the moon provoked less procrastination.
When the Americans decided to go to the moon, access to space was relatively new. The Americans hadn't yet carried out an orbital flight, hadn't yet done a space link up above the Earth. No one had managed to place a small autonomous probe on the moon.
But at the time, East-West rivalry was at its height. It pushed space conquest towards a destiny which no one yet imagined.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Today we've somewhat forgotten, and from a technical point of view, we now consider ourselves much nearer to being ready to send men to Mars in a dozen or so years than the Americans were to sending men to the moon in less than 10 years during the 1960s.
Today, after the Mir space station's inauguration of East-West cooperation in space, at a time when 15 nationalities work hand in hand for the ISS, the political context is no longer the same. Not to mention the economic context. To set foot on Mars would cost between $150 and $300 billion. Clearly, President Obama doesn't have the budget to play at being Kennedy, even if he tries to follow in his footsteps.
By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow, and I expect to be around to see it.
So in the United States, landing a man on Mars has no fixed date, and even less so in other countries. We'll have to wait until 2040 or even 2050. Unless private companies overtake the space agencies. Billionaire co-founder of the PayPal online payment system, Elon Musk has set up a space corporation, SpaceX, which sells its services to NASA. He built his Dragon spacecraft, already used for the ISS. It is to be adapted for Mars, with a landing expected for 2018, with no astronaut aboard. For a manned mission, the timescale is more vague.
On the Mars thing, would you send up some people?
I think if things go according to plan, we should be able to launch people probably in 2024 with arrival in 2025.
As technology stands at the moment, 2025 hardly seems achievable. Even more so because landing on Mars isn't enough. You need to take off again. No test has ever been carried out for taking off from the red planet. So some are tired of waiting. Jeremy is a doctor on reduced gravity flights. He's crazy about Mars.
At 20, I was struck with admiration reading an article about manned missions to Mars. And I wanted at any cost to see that with my own eyes. And I was very surprised to see that projects are always getting pushed back. At the time, they were talking about 2020, that's my generation. Today, there's talk of another 30 years, so something has to be done.
There are 200,000 of them who want to go, as it stands right now. After selection using psychological criteria, there remain 100, including Jeremy. 100 candidates for a Dutch project, the Mars One mission. A project which is, let's say, out of the ordinary.
The space agencies, if they're not going to do it, we have to start doing it ourselves.
Mars One's mission is one of permanent settlement, a one-way trip. We'll establish the first human settlement on Mars in 2027.
Many people have called Mars One a suicide mission.
in that we will go somewhere and we will die.
No return is envisaged for the settlers aboard Mars 1, awaiting that perhaps one day technology will be in place to bring them back to Earth, a project which clearly poses ethical questions.
Obviously, if society wittingly sends human beings to a planet and they don't come back, this poses a problem from the social ethics point of view, which is difficult to resolve. However, it can be resolved in terms of individual ethics, where I confront the questions, I'm fully aware of what I'm doing, and I'm ready to take the risk because it is greater than myself, because it's a valorization. I think that a life is part of something, which goes beyond itself, which is something collective.
Projects like Mars 1 merit serious reflection. They shouldn't be taken lightly. They're proposed by contemporaries who are highly motivated. They are also, in their own way, explorers. We must at least credit them with that. And they tell us something about ourselves.
Perhaps they tell us their doubts about a society ruled over by the principle of caution. In any case, they're ready to face any risk, even if they have a family, like Jeremy.
How can one envisage, as a father, as a loving person, as someone very happy on Earth, a project as extreme and radical as this? Well, it's dealt with by being very present in one's life as a father and husband. It's being aware of the importance of living one's life, not putting life on hold, living the present moment in a very, very intense way.
3, 2, 1.
Jeremy isn't sure of leaving. Out of the 100 candidates still in the running, 6 groups of 4 will be chosen and will leave one after another. Financed by investors, advertising and television projects, the enterprise could cost $6 billion. An impossible budget to come up with, according to numerous experts. I refuse to envisage this one-way trip to Mars. For me, the return trip already seems sufficiently problematic. The biggest unknown is the psychological aspect, what will go on in people's heads when they lose sight of the Earth. It's never happened before, and above all, they'll be totally alone. How will we live this extreme isolation? In Hawaii, they're attempting to narrow down the problem. On the slopes of the Mauna Loa volcano, the simulation mission High Seas 4 is set up, financed by NASA. Its objective? To study the behavior of an enclosed group over the space of a year. No direct communication with the exterior. The group films itself.
I just got a photo from Earth. My hockey team won their championship game yesterday, so there you go. Go Flyers.
Go Flyers. All right.
Their water and electricity resources are limited, as they would be on Mars. Life in a jar for 3 women and 3 men. Cyprian is the biologist of the team. His role, to grow plants.
So that's going to be our first lettuce. It will not be much for the crew because it was just a test, but I think people will be happy to eat it anyway after 2 months without fresh food. Actually, there is, as you can see, there is no soil. It's just a hydroponic setup. So if you have water here with all the nutrients the plant need, and you can see the roots.
Imagine living with 5 roommates who are also colleagues. Imagine never leaving the apartment, so you're all the time with these 5 people and you see no one else. It's difficult, not to say impossible, to constantly hide your bad points for a year, so you see your teammates in their worst light.
Knock, knock. Hey.
We're always in the same place, always with the same people. For the last 10 months, I haven't seen or spoken to anyone outside my 5 teammates. I think the most difficult part is the fact of never being outside, because even when we do go out, for a geological mission outside the dome, we wear a spacesuit, so you never feel the wind or the sun. Everything you touch is through gloves, and everything you see through a visor.
This mission will demonstrate how the attitudes and interactions of the team members evolve over a year. But whatever the results of this study may be, I'm sure of one thing. We will leave. We will leave for Mars. Because for me, leaving is in mankind's nature.
You have to recognize that each time man has been confronted with a different world, progress has resulted. When our ancestors left Ethiopia to spread across the world up towards countries where it was colder, they needed to invent clothes, to invent fire. Then man adventured onto the seas. Vessels needed to be improved and navigation invented.
When we invented the aeroplane, we knew very well that the whole point of it was to one day be able to cross the Atlantic, for example. But we weren't capable of doing it. We developed the technology, and then we set out. With Mars, it's the same thing. Today, we don't have the technology to go there, but we will develop it. We'll do our own crossing of the Channel, the Atlantic, and one day we'll be ready. Yes, one day we'll be ready, and following in the path of Magellan, of Christopher Columbus, and of Lindbergh, we will open this new horizon. We will make the Red Planet a land of welcome.
Touchdown confirmed. We're safe on Mars.